Then the fourth question, if you see in the looks of it, you can say simply it is a transshipment question. So just giving it a quick glance, we are shipping goods from Europe to US. So Europe is your source, your destination is US, and the costs are given. Now the context is if you are sending goods directly from Europe to US, they are saying there could be tariffs. Here is what they're saying that manufacturing of laptops from Germany, Belgium, and Italy because of high tariffs between international trade groups. Sometimes it is cheaper to ship partially completed goods to Puerto Rico, basically South America, and then yes, any doubt, anyone? Okay. So then you're sending them to South America and then finally to US. So before sending them to US, if the transshipment is followed, you are doing the remaining parts. Matlab they are partially completed. You're shipping partially completed ones to South America and then to US. So the individual costs are given. The cost per unit of the completed laptops plus tariffs and shipment costs directly are given, and then below are from the Europe to South America and then South America to US. These costs are given. Now the question says determine the optimal shipments of the laptop that will meet demand at the US distributor at the minimum cost. So briefly, the question is goods are there in Europe. They have to go to US. These are the costs when you are directly sending from Europe to US. These are the costs if you are using South America as intermediate node. Now tell me for formulate a proposal so that you state cheapest cost is achieved. I want to send the goods. And this is the supply. So the supply, if you see Germany's supply is 5,200. This is in thousands. Though don't forget to just convert it into thousands. 5,200, Belgium it is 6,300, Italy 4,500. Base same I have converted it into Excel. See, I'll do one thing. Is it fine if I explain or do you want me to solve it? Quickly, please. Okay, I'll take it as explained. The,
Explain.
yeah. So these things, we have just entered the data from the entire graph. Now, right now what I'm doing is I'm doing direct shipment. Directly, I'm trying to ship from Europe to US. So these are the costs as given here. See, same cost 2,600, 1,023, and all the costs are given. Then look at the supply and demand. This is the supply 5,200, 6,300, 4,500, and the demand is 2,100, 3,700, 78. Whenever you're doing these problems of supply and demand, always do total supply and total demand. If you don't do that, you will not get understand the crux of the problem. The total supply is 16,000. This is the total supply. Just sum it. See at the bottom, you can see the sum. See that the cursor 16,000. And the total demand, this is the total demand. Again, see 13,600. Now your demand is greater than supply, means you have enough supply to get entire demand. So at demand equations, you put equal to, and at supply less than equal to. So you can utilize as much of supply as you want to satisfy the entire demand. That's why you are putting equal to. Now this, let me just put zeros so that your solver shows you the values. Now this is the cost, and these are the number of units to be shipped from this particular source to this particular destination. Then this is nothing but the auto sum of these three columns, and this is sum of the rows. And this is your sum product, which is nothing but the cost associated and the number of products shipped. When you are shipping directly from Europe to US, what is the cost? So that just let us see. Going directly into solver, reset all. Then this is your objective function, minimize it, changing these values, then putting your constraints. Now don't forget this is direct shipment. We are not doing to anywhere from directly from Europe to US. Then okay. Then simplex LP solve. Solver found solution. So this is the direct cost. Right. You have got the direct cost. See the supply. 5,200 completely utilized from Germany, 3,900 from Belgium, 4,500 here. But entire demand is met. Whatever has to go to Texas, Virginia, Ohio is met. That you have to ensure. This is your total cost. But they asked us to find the optimal cost. So how do you find the optimal cost? You can send some units directly to US and you can send some units from Europe to US. That is partial shipments, both Europe to US and then Europe to excuse me, South America and then South America to US. So Europe to US and Europe to South America, then to US. So how do you send it? So then Europe to US, what are the sources? All the Europe's port, Germany, Belgium. This the columns are the sources. The column values, what are written in the column, these are the sources, and these are the destinations. Here, what are the sources? You are sending Europe to US, and again you are sending Europe to South America, then South America to US. So Europe is the source, South America is also the source. What is the destination? US is the destination, and also South America is the destination. So those cost values we have written. Europe is the source. First three Europe has come. Then South America is the source. Why South America is the source? Because from South America we are sending to US. So that is also our source. Then here South America is the destination. Why? From Europe you are sending to South America, then South America to US. And ultimate destination is US. Simply put, what all are the sources can come? Transshipment, right? So you can send from S1 to intermediate node to destination. So you have put source and intermediate nodes here. Then here you have put intermediate nodes and destination. Then the respective cost, whatever the cost is given in the question we have put, these costs are put bigger values so that this route is avoided because there is no such route. You see what is the route? Puerto Rico to Puerto Rico. Both are in South America. You can't send goods from the same value again and again. You have to send it to somewhere else. Right? From Mexico to Mexico, you can't send them to the same location. You have to send it to somewhere else. So these costs are entirely from the question itself. Then how many goods are you sending? That is what we have written here. Here, if you see, okay, let me also do this from first. I'll try and just solve it again. This is completely zero. Nothing is moving from anywhere else. This is quite simple. From Germany, the same entire supply less than or equal to symbol is put. Then for the US destinations, the equality symbol is put. Then for these ports, see when Puerto Rico, how many, this is the source, right? Puerto Rico is the source. Those goods which are entering into Puerto Rico should leave Puerto Rico. Means those incoming should be equal to the outgoing. Like I have explained in the video, those many nodes or those many goods which are entering Puerto Rico should leave Puerto Rico. Or you can also use buffer concept here. It is up to you whichever concept is used. I'm using this concept because here there is no need for buffer. Without buffer also you can do it. The goods which are incoming to Puerto Rico should be equal to the goods which are outgoing to Puerto Rico. That is how we equate it. Similarly, the goods which are incoming from Mexico should be equal to those going out from Mexico. And that also from Panama.
Raghu,
Yes.
why there is no need of buffer?
Here, buffer you use it when the destination is also source is acting as a destination, or one destination you can send it to another destination. Right. Here, if you want to use buffer, you can also use buffer. That is not an issue.
We can maintain the intermediary nodes directly by buffer, right?
Yeah, you can send without keeping the buffer also. Just equate these three nodes with these three nodes.
Okay, and in case we use buffer concept, so we'll just
You'll just put
equate
the
these nodes with.
maximum value because 16,000. So you'll just add buffer
Mhm.
here and here because those are intermediate nodes. And source and destination will
Oh,
not be adding anything. Only those intermediate nodes we add the
yes,
buffer and you can solve it.
we'll get the same answer.
Yeah, you'll get the same answer.
Okay.
Okay, now let me just solve it here. So this is your objective function, minimize the cost, changing the variables, changing these variables, constraints, these. Now see how I am adding this. These three values I'm equating them exactly to those same order again. These three in the column wise equating to the row wise in the C. See, Puerto Rico, Mexico, and Panama. Puerto Rico, Mexico, and Panama. Simplex LP. See the cost, 241, 60,000. So here they're saying send some values directly to Texas. See, from Puerto Rico to from Panama. No, from Germany you are sending directly to Virginia some products, and some products you are sending from Germany to Panama, then from Panama to Ohio. Means from Europe to South America, then South America to US. So that is clear. Then just write one statement. This is shipment from EU to South America. You can write combined shipment from EU, South America, US is cheaper than the direct shipment from EU to US. EU to US. Okay, so fourth question is done. You don't have any sub questions in the fourth one. Fourth question is clear, everyone. You can, for this thing, you have to draw the network. I think you know how to draw it. Just the nodes. Put the nodes and put the arrows wherever you have the cost and write the cost over it. That I believe it is quite simple. Same like AON, just put Germany at one, all these nodes at one part and distributor in one part and connect the dots, connect the lines. That's all. Nothing big as network and all. Model output is what you write, and model is nothing but how the solver has solved it, and network is the diagram you have to draw. So just draw the diagram for this. Fourth question is clear, I guess, for everyone now.
Exactly, just one doubt more.
Yeah,
If you would have added buffer, the supply constraint would, for that three values would have been also less than equal to 16,000, right?
let us see.
Um, the last,
Yeah,
because I am getting another value if I'm maintaining a buffer.
how much you are getting? What is the value you are getting?
It's way too beyond, I guess. I might have done some error, but
Let us see.
You have written 1600, right? In supply period.
Supply, sorry, 1600. Acha, okay, okay. Thank you. Minimize this, this.
buffer on the demand side would also be less than equal to.
Demand side. Because why are you putting equal to? Because those do not need, no?
Because demand was lesser than supply.
But that
So we
demand is for
wanted
the
that.
destinations, no?
Mm-hmm.
Let us
हाँ
see.
ठीक है okay then less
Let
than
us see.
equal to
You are getting much less. This one,
yes
1,08,007. Let us see what is happening. Now, if you see here, Mexico to Texas, Panama to Virginia, but no
mm-hmm.
goods are coming from Germany, which is wrong. Goods have to move from Germany. See the solution also, not just the cost. See the solution. Solution, goods are not coming from Germany. Germany is your source, which means this constraint is not being satisfied. So somewhere it is going wrong. Where are we
No, so
going
what
wrong?
I did was I maintained less than equal to on supply and equal to on demand, and
Okay.
then and maintained the buffer, and then every path had some values, but the cost was way too high. I mean, it's costing around 35. lakh something. 35,036 60,000.
Let us see if we put equal to what happens. This is why I don't prefer buffer, because it will not work some of the times. This 35
Yes,
is
this
skewed
value.
quite high. What is the demand? 13,600. This is also not correct, because things are off with this. Germany 252, Belgium 63, Italy 45. Entire, see this thing. Entire supply is used, but entire supply should not be used, because that is not necessary at the demand. Okay, then let me put 13,600 and see what happens.
लास्ट शिपमेंट की वीडियो भी देखनी पड़ेगी
2783. This is wrong. I don't know why it is not working, but this part is wrong. So
I mean,
don't.
I didn't know how to solve intermediary nodes without buffer. That's why, because uh, we were being taught क्लास में भी intermediate nodes में buffer maintain करना है. So मतलब मैं अगर ये attend नहीं करती तो मैं buffer maintain करती, तो उसके बिना कैसे होता है, मतलब how do we do that then? मतलब
Without,
कैसे decide करेंगे कब करना है and when not?
when you are unable to formulate these equations, right? When the outgoing and incoming are equal, then is when you, that is one way to get to add buffer. Or you can also say, uh, when you are having a source which is also destination, or source which is also acting as the other, means source acting as a destination, destination acting as a source, then also you can go to buffer concept. Like, just wait. So your nodes, when you have like this simply, right? So whatever is coming, incoming to these nodes. Now, if you see the intermediate nodes, their incoming is not stored anywhere. Whatever is coming here should be sent out here. And whatever is coming from here should be gone out from here. This is incoming is equal to outgoing. This is basically what we have done in this solution. This is the incoming, and this is equal to outgoing. So for Panama, they have 7,800 incoming and Panama has 7,800 outgoing, because Panama are the intermediate nodes. You can't store anything over there. So whatever comes to the middle nodes, it is sent forward. It is not stored. So in that case, you can simply use this concept. Incoming is equal to outgoing and do it. But if you have scenarios where there is one destination node, this is also a destination, but still there is a path from destination to destination, then you can use buffer. Right?
Okay, all right.
When you're having a destination node which is also acting as a source node, or if the source to another source, or this kind of scenario, then you can use it. When this doesn't hold, simply putting, when this input output concept you think is not holding, then you can go to the buffer.
Okay.
Yeah. Okay, let us see the third one.
रघुनाथ
Yeah.
एक डाउट है
हाँ
go back to the image now.
हाँ
Here, if in the middle two nodes, the warehouses which are there, if we have a connection in between them, then we don't use buffer.
when you have a node between them, because see, now
Because then
incoming and
your
outgoing
incoming
is not
outgoing
valid,
is
not valid, so you
different,
have
no?
to use buffer.
Yeah, so we'll have to use a buffer in such situations
Yes, yes.
also, right?
Because incoming and outgoing is not well because you don't know how much is incoming because one can come
Okay.
from that way or this way and go like this also. In this case, you don't know what is incoming, what is outgoing. Then you should go for buffer.
And then in this case, the buffer will be added only to these two nodes and not to the entire starting
Yeah,
and
only
ending
these two
ones.
nodes.
Okay, cool.
Hmm. Okay, so the third question, let me just run it because we don't have much time, only 9 minutes of recording is less. So this question, they are mixing three different items, three different products, which are called as white wine, rose wine, and juice. They are trying to make a drink, which is basically a composition of these three things. And they said that this is the cost. Cost of white wine, 1 gallon is $1. Rose wine is $1.5. Juice is $0.5. And the constraints are like this. See, white wine's composition in the final drink, in the final mixture should be greater than or equal to 50%. Then roses should be greater than or equal to 20, and rose between 20 and 30, greater than or equal to 20 and less than or equal to 30. Juice should be exactly 20%. And white wine, you can purchase it only for 10,000 gallons. That is, the supplier cannot give you more than that. That is one more constraint. Rose also the same case, not more than 8,000 gallons can be provided to you. So these are the constraints. We have 1, 2, 3, 4, 5, and 6, all the 6 constraints. Right, these are the 6 constraints which have been translated like this. How do you translate like this? They said wine is greater than or equal to 50%. 50% of what? Of the entire mixture. So consider these variables are W, R, and J. W, R, and J. W is the number of gallons of white wine in the final mixture. R is the number of gallons of rose in the final mixture. J is the number of gallons of juice in the final mixture. The final mixture, what is the final mixture? You don't know it because you don't know these values, W, R, and J. Variably, how we will write W plus R plus J. This is the final mixture, right? Because W gallons, suppose say W is 5, R is 3, and this is 2. This is 2. So how many liters of mixture have you formed? 10. Now they said W should be 50%. Is it 50% or not? How you will check? 5 by 10, na? 5 by 5 by 10. Why 5 by 10? 5 is how much W is. 10 is the total liquid value. Correct? That is understood, right? Similarly, now they are saying 50% of white wine in the mixture. How will you get it? W by W plus R plus J. This value is less than or equal to 0.5. Clear? If this is less than or equal to 0.5, bring this denominator to the right hand side of equation. That will become how much? W is less than or equal to 0.5 into W plus R plus J. Okay. Now take this to the left hand side. Means minus 0.5 minus 0.5 R minus 0.5 J. That will become how much? Here we are having 1 plus 0.5. 0.5 W minus 0.5 J minus 0.5 R less than or equal to 0. Why did we do all this? Because these are the coefficients. This is the constraint. See the coefficient of the constraints. 0.5 minus 0.5 minus 0.5. Then that is, oh sorry, this is greater than or equal to. Greater than or equal to 0. Why greater than or equal to 0? Because greater than or equal to 50. Similarly for rows. For rows, how you will do it? Rows is greater than or equal to 30. Rows divided by W plus R plus J. This is greater than or equal to 0.2. Now take this numerator to the right hand side and bring these equations to the other side. You will get how much? Minus 0.2 W plus 0.8 R minus 0.2 J. Put the equations on the paper. It is quite easy to understand. Try to put it on the paper. If you are not understood how to make the equation, I have explained it. W by W plus R plus J. That if you are not understand, ask me right now. Because we don't have time. Meeting is going to end. That's why. Once you form that equation, carefully find the coefficients and sometimes write in the same order, W, R, and J, even while you are writing. Sometimes you might mix the coefficient, you not get the correct answer for it. So once you got the coefficients, these four are the same coefficients. First one is 50%. This is R is greater than 30% and less than 30%. J is equal to 20%. And this one you see, the composition or how many gallons of W can be, it has to be less than or equal to 10,000 because the supplier is not ready to provide more than 10,000. Similarly for R is less than or equal to 8,000. Then Z is how much? They said this is total profit. This is maximum because this is a profit. How you got the profit? See the formula bar. 2.5 is the selling price. Selling price into the total gallons. Final weight is what? Sum of all those gallons minus sum product of the cost. Cost into gallons. Cost into gallons. So you are reducing the cost, total revenue minus total cost. Simple. This has to be maximized. And what is LHS? LH is nothing but sum product of these coefficients with these values, where you are locking the gallons to buy with function F4 key. I hope that is known to all. Right. So this part is clear, right? It is simple how to solve this LPP. So if you see the further questions, is the cost of the wine and fruit juice a sunk cost or relevant cost in this situation? It is a relevant cost. Relevant cost means if these values are changed, the entire profit could be changed. Sunk cost means it is a capital cost, fixed cost, which has already been expensed, means it's already been used. The cost has already been utilized, the capital cost, machinery cost, and all. Relevant cost means which is dynamic, which changes because of which the decision changes. That is the relevant cost. So these are relevant costs because if you reduce the quantities of purchase, like the gallons are increased or decreased, the profit will change accordingly. That's why it is called as relevant cost. That is simple. Then if Mimosa could obtain additional amount of white wine, should they do so? If so, how much should they be willing to pay for each additional gallon? How many gallons would they purchase? Yeah.
Raghunath didn't get the sunk cost, relevant cost.
Sunk cost is what you have already spent, which is not changed or which is fixed. Capital. Capital is fixed. Now you are finding buying a car. The capital cost is fixed. Maybe it is a taxi business. That is fixed. But relevant cost is the price you are charging for your customer. A taxi guy charges the customer for the services. That price varies depending on how many customers, how far you travel. That is relevant cost. Fixed cost, sunk cost means it is already done, it is not changed. You cannot change while changing these values.
Okay.
Right?
ठीक है
क्लास में तो इतने क्वेश्चन पूछते नहीं है लोग हैं
क्लास तो आते ही नहीं सर
आते ही नहीं चलो अच्छी बात है okay now see this thing this part is explained in the first video of LPP in my videos. Just if you want, just look at over there. You have the sensitivity report. I think you already know how to generate the sensitivity report. Quickly look at this E part. Interpret the dual value. Dual value or shadow price, both are same. So don't get confused because of dual value and shadow price. Dual value and shadow price both are same. Interpret the dual value for the constraint representing to the requirement that wine cooler means the mixture, the entire mixture must contain exactly 20% fruit juice. What is your advice management to this? So where is that constraint? That 20% wala constraint is for the juice is here. So this is nothing but L12. So see the report L12. L12 the shadow price is 1 unit, means shadow price is positive, and the allowable increase is 2000, which means you can bring 2000 more units of the juice. That is what is written. For juice, shadow price is 1, allowable increase is 2000 units, which means unit increase in the right hand side of constraint increases the profit by shadow price. Management should increase the juice content. That is a simple answer. Similarly, if you see for the other value, the D part of the question, look at the question later, the shadow price is negative. So management should not increase because if this value is increased, the profit will reduce because the shadow price is negative, minus 2.4. For rose wine, the shadow price is 0. So there is no use